So that takes us to multiplying probabilities together. As long as two events are independent of each other, and you want to know the probability that both will occur, you can multiply them together. So like let's say you flipped a coin, right, and there's two outcomes, heads or tails, and let's say you also rolled a die, so there's 6 outcomes. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Alright, and let's say that was a 5. Okay, the probability of flipping a coin and getting heads, and then rolling a die and getting a 5, is 1 out of 12. Now, one way we could do that is to see, alright, there's 12 possible outcomes here, and there's one way it could be heads and 5s. Or, you could take the probability of flipping heads, which would be 1/2, and the probability of rolling a 5, which would be 1/6, and multiply them together, and get 1/12 that way. So, again, you can multiply probabilities together as long as you know they're independent. And you can usually either say it or you can figure it out by the context of the question. So here's one. So let's say you have a random number generator on a computer. You can actually do this on your TI Nspire. If you just type in, I'll show you in a second, but you could do random number generator on your calculator. Let's say it selects 3 integers from 1 to 20. What's the probability that all 3 numbers are less than or equal to 5? Okay, so if we open up our TI Nspire and go to a new calculator, and then hit Menu, Probability, Random, Integer, and then type in 1, 20. Okay, it'll give you a random number from 1 to 20, inclusive. Now, notice how these are independent, right? I got 2 6s back to back, because the probability of getting a 6 is always 1 out of 20, no matter what, even if I just got 2 6s. Okay, so these would be independent events. Okay, so now, what's the probability if I did that all 3 numbers were less than or equal to 5? So, since they're independent events, I'm going to multiply them together. Alright, so we got 1, 2, 3, 4, 5. There's 5 ways to get a number less than or equal to 5 out of 20 numbers. So on the first click, that'd be 5 out of 20, which is 1/4. And then it'd be times 1/4, and then times 1/4 again, because I'm doing it 3 times. So the probability all 3 numbers are less than or equal to 5 would be 1 out of 64. Now let's take the same question, but change it a little bit. So again, we got a random number generator, and it's going to select a number from 1 to 20, randomly. What's the probability that exactly one number is less than or equal to 5? Alright, well, you might be thinking, well, if there's a 1/4 chance that there's a number less than or equal to 5, which there is, and there's a 3/4 chance that there's a number greater than 5, which is also true because of the complement principle, right? If there's a 1/4 chance there's a number less than or equal to 5, then there's a 3/4 chance there's a number greater than 5, because there's a 100% chance both those things happen. Alright, now the probability, if we multiply this out, 9 out of 64 is actually not the right answer, because this would be the probability specifically on your first random number that it's less than or equal to 5, and then the second number is greater than or equal to 5, and same with the third number. The reason why it's not correct, because you can also do, well, let's say the first number is greater than 5, but the next number is less than or equal to 5, but the third number, or the second number, the third number is greater than or equal to 5. So that's also 9 out of 64. Or the first 2 numbers could be greater than 5, and the last number is less than or equal to 5. So there's 3 different ways you can get one number less than or equal to 5 exactly once, so that the other 2 times are greater than or equal to 5. So you have to add all those up and get 27 out of 64. Now this has to do with another counting principle thing. That 3 has to do with, out of the 3 numbers, choose one of them to be less than or equal to 5. That's where the 3 comes from. So this is going to look a little bit like something we've done before. So in the next video, I'll show you how to do this problem. So think about it on your own for a minute or two, and then I'll walk you through it, and then I'll show you like a little formula you can use for these types of scenarios.